Okay guys, so after the steps, so let us continue with interactions, where at the interactions here you have two options. You can use the interactions or either you can use constraint. So for this I use constraint. Okay, so constraint I will name it as the top. Okay, and then I will use coupling. Okay, here you have many types according to your need. You have type, rigid body, display body, adjust point, MPC constraint, shell to solid coupling, embedded region equations. So if you use embedded region, this is for the reinforcement in the reinforced concrete, okay, which is the reinforcement, the steel bar is embedded into the concrete. And also you can use type if let's say that two surfaces being tied together. Okay, in between the surface normally is for the surface like the sandwich system. And rigid body is the rigid body that you have, let's say you have a body that is rigid and then you want to tie to certain part, then you can use the rigid body. So for this I'm going to use coupling. So continue. Okay, so here it will ask you to select the constraint control point. So but then I already have the set that just now I create. So I can press on the create button. Then here I have the RP tops. So if you want to confirm that is it true that you select the correct one, so you can highlight the selections in viewport. So it will show you the parts that you select. So correct is using the RP top. So continue. Okay, and then select the constraint region type surface. So here if you haven't have the set, so you need to create the set, the new set. But I already have the surface that I create in the assembly in the previous video. So I can click on the surfaces. It's not come out, sorry. So here is not come up. Okay, then it's wait a minute, let me check why it's not here. So just now in the assembly, the RP top, RP surface, it is not considered. So here I'm going to create the surface. So I will name it as surface on top. Okay, then I'll select the regions here. Okay, so here you already have the surface. I'm not sure why just now having some errors, but it's okay. You can create the sets here. Okay, the surface on top, and then you constrain the whole surface to that control points. Okay, the constraint degree of freedom U1, U2, U3, UR1, UR2, UR3 means the rotation and the displacement. You will follow this RP top. So okay. So also for the bottom, you also need to do the same. Where now you can go to the constraint. You can see that already have a top. So you repeat the same process and then you use the bottom, and then coupling continues. Okay, so the set is here there, and then to use the RP bottom continues, and then the surface, and then here don't have the surface yet, so I will take it to the surface, and then I will select this area. Surface bottom. Okay, done. Then I click shift, done. Okay, click done. So now you can see that the surface area in purple color is the surface of bottom, and then the control point is the top, the RP bottom, and then constrained all degrees of freedom. Okay, so it's here. So okay, done. So now you have the top and bottom constraint. Okay, so after complete the constraints, then we need to move the boundary conditions. So as I explained before, okay, you need to follow the step by step. So now we go to the loading and the mesh. The boundary condition is the same procedures as at the same step. So we can go through you can see that here you have the load manager. Okay, boundary condition manager. You either can apply the load directly or either you can use the boundary conditions. Okay, I will use the pre-described displacement. So I'm going to the boundary conditions manager at here. If you do want to click here, you can go to here also. Here you also have the same thing, boundary condition manager. Okay, then you will need to create on top. Okay, see, so BC top. Okay, then I will use the displacement or rotation. Okay, and then select the top, so I will use the RP top, continue. Okay, so at here I will click all of it, means that the boundary condition is applied on top. So the U2 here I will going to put negative 10 millimeter, means that from 0 to 1 the circle, okay, I'm going to apply 10 millimeter towards downward, okay, in total. So here the amplitude is how the load being applied. So I will use the tabular, so I name it as tabular. Okay, so it will start from 0, when 0 the time second, and then the amplitude is 0, and then it will increase gradually from 0 to 1 accordingly. Okay, so select the amplitude, tabular. So this is okay, done. Okay, so create here, move at the initial, you need to move to the left, but then here when you create the initial you cannot have the non-negative value, so you have the value first and then move to the left and then propagated. Then here you can change to negative 10. Okay, then done. And then another same way method also, you need to create for the BC bottom. So you use the displacement rotations, continue, and then at the RP bottom, continue. Okay, so again you click all and then you choose tabular here. Okay, so RP bottom created here, then you move to the left and then it's propagated. So for the bottom we will not have any displacement, so we just leave it there, so it's not going to move. Okay, so done, dismiss. So now you already have the boundary conditions. And then I want to remind you is in the abacus you will not auto save the file, so you need to save from time to time, because if you accidentally close this CAE, okay, then the file is not going to save until the stage you're done. So from time to time you just click this diskette button, so you will save. So after the load, then we go to the mesh. Okay, so at the mesh here you can see that we haven't have any mesh yet, so you need to apply the zip parts. So here you mentioned dependent part instance cannot be edited or assigned the mesh attribute. So normally at here we need to change it at the assembly. Okay, and then at the parts here, then we right click. Okay, then we can click here. Okay, then we make it independent. So once make it independent, you can mesh. Okay, so you assign it, you click this. Okay, and then it will come up with global seed. It will ask you to assign the global seed. So if higher the value, the more cost the mesh, and then if the lower value, it will have lower case. So mesh, the more fine mesh. So here I leave it at 15. Okay, so you can see that this is the global seed. So I can show you the example. Let's say I want to change it to 10. Apply. So it will have more. It will become more fine. So at here, this example, I want to show you just roughly 20, because I just want to show the example. So here, mesh part instant. Then I will plan to click this. Okay, to mesh the part instant. Yes. So if you have a composite panel, it might ask you to select the whole area, which area you want to mesh, because sometimes you need to mesh separately. So then you can see that this one is already been meshed. So you can click the save button for the mesh. So before you proceed to run the job, so you need to go to mesh element type to check what is this type. Okay, so you can see that these are foam concrete whole cube is the set that I created before. So you can check that. Make sure your elements library you use the explicit, because we use the explicit. Okay, and then at here you can see that it is 3D here. So make sure you use 3D stress, and then it's a hexagon. It reduce integration. Okay, and then here you have quadratic, and then you have linear. So we leave it there. Okay, we use the linear, and then if you want to change to other types of the element control, you can use here. I will use this. Then okay. Okay, so dismiss. So after the mesh, then you will go to the job. So job here basically you already complete the whole model. Okay, so you can create a job. Here you can click create. Okay, create for job. So mesh 20 here I mentioned. So model 1 here, continue. Oh, you cannot have a spacing, sorry. So you can put mesh 20. Okay, without space. So okay, you click run. So before you submit, you can do the data check first. Data check is for you to check whether you have any errors or not, because sometimes we might not find any error, or we may make any mistake during the step. So what you have to do is you can have a checking first. This is also prevent you to waste time on the submission, let's say if you have any errors. So it will start to check the whole model. Is there any very obvious errors that can be detected? So if not, then you can see that it's check complete, then you can click submit. Means you will submit for the job. Okay, you will start running the full analysis, and then if you want to see that here you have a monitor, results, and queue. For queue is you want to stop the analysis, you want to stop it, then you click clear, it will directly stop the analysis. And then if you want to have the results, and then you can show the result, but when you are running, if you click the result, it will only show you once the result, and then it's incomplete. And then what you have to do here, if you want to monitor how it's run and then the progress of running, then you can click on the monitor. It will show up this window for the monitor. You can see that here you have step, increment, total time, CPU time, step time, stable time, and then the kinetic energy and the total energy. So the total time here, because we put in the circle, remember just now the tabular you put in 0 to 1, means that from the total time become the 1, means the process the whole analysis already being completed. So it means that later you can do the post-processing, which is the results. You can see the results. So this one you need to run until it become 1. Okay. So in next video, I'm going to show you on how to do the post-processing. So see you again, guys. In next video, I will explain to you on how to process it. Okay, bye-bye.